Okay, hello. So we are starting off with 6.1 logarithms, chapter 6. So this is mainly the algebraic portion. I'm gonna do the graphical portion later. Okay, so uh, assuming you guys did, do class and you actually, were taught, you'd know the first few questions, like you know how to do them. So I'm gonna just start off with like question 5. But before that, these are the laws of logarithms. You're gonna need this, a lot. Most of the algebra portion is just this, but like a bit tricky. They, a lot of manipulation. So memorize these, remember them carefully. Made a little angel here because they're important, I guess. But I'm just bored, I guess. Okay, so starting with question 5. This is where the tricky stuff, starts to happen. So this is basically just changing the base of a logarithm. So first off, I'm going to derive a little small thing for you. So x is equal to log a b. Uh, so this is the base of the logarithm, and this is the argument to the logarithm. So let me write this a bit better. This is the argument of the logarithm. So I'll be using these terms a lot, so remember that. So log x is equal to log ab. Right. Now ax is equal to b. The thing is we have to see what do we have to raise this to get the power of this, right? Now to change the base, let's ignore that. Let's change the base. So let's say we want to change the base to c, right? C. So we would have to do this. So log c ax is equal to log cb. And from here you can write x is equal to log c, and this is the argument, over log ca, right? So this is just when we want to change the base of something. So log a and log ab, we want to turn into this. We want to turn into log cb, right? We want to change a. We want to replace this with c. So you have to do all of this. So let's use an actual thing as an example. Okay, so this questionnaire. Now base 2 is just c equals 2. So from here, and you can see that, what is it? You can see that this is b and this is a. So if we use the rule that we showed before, so log 425 is equal to log c, so log c over b, and then log ca. So this is just the same as log 2 of 25 and log 2 of 4, right? Now, using the rules of logarithms, we can see that we have to square 2 to get 4. That means this is just log 225 over 2. That'd be better. Log 225 over 2. Now, when we divide something by 2, that's the same thing as multiplying it by 1 by 2, right? And we can all agree on that. So from here, what you can say is that, okay, what this is it's 1 by 2 times log 2, and the argument's 25, right? So if we use the algebraic rule that x log ab is equal to, log a to and basically we have to just move this here, right? So this is gonna turn into log 225 to 1/2 power. Now what is this? What is the 1/2 power? That's the same thing as a square root, right? So, let me move this here. This would be log 225 square root. So log 2, 5. That is the answer for question 5a. I know a lot of people have some issues with this. Maybe the teachers explained this well, but like, this is a bit confusing because you skipped a few steps. If you just show every step, it's much more easier. So the next question, similar. Now that you guys could do that, I'm not gonna, hold your hand anymore. You could probably do this easily as well. Let's say for B, okay? Log 310 to base 9, right? So what we can easily, if we follow the steps, we can just say that, okay, x is equal to log 910 over log 9, 3, right? If we just, follow the identity that I derived before. So, okay, this looks a bit messy, right? What are we going to do here? So, let's keep log 9, log 910 here. But, let's see what we can do here. What do you have to, raise how do you raise this to the power to get 3, right? What do you have to raise to the power of? So we know that the cube root, or the square root of 9 is, it's 3, right? So square root of 9, what is a square root, right? What is a square root? Square root is just 1/2 power, right? So, yeah. So from here, you can write, okay, then it's 1/2. Now, what's this, right? What's this? This is the same as this, right? You can repeat on that, right? Then from here, you can write down this, right? Reciprocal. Oh, sorry. Right? This is just 2. So in actuality, this is just 2 log 910, right? Now, like I said, move it here. Law of logarithms, right? So log 9 is equal to 100, or log 9 100 is the answer. 100. So that's a bit trickier, but it's kind of fun. So next one. Now, before I get to C, I want to explain one small thing. It's called E, right? This is what this is. It's called Euler's number, right? So what is Euler's number? Euler's number is it's the same thing like how pi is an irrational number, right? It's a number with an infinite amount of decimals, right? So, and you can't really put this as a fraction. So this is E, right? You don't really exactly need to know what E is used for, because it's supposed to be a constant in statistics, right? But you use it a lot in algebra as well. So this is very prevalent in algebra. You'd probably use it more in algebra than you'd use it in statistics. But from here, E, right? And now there's another small thing, is an ln. ln is just log e to x. This is just ln. So this is ln x, right? Same way how lg is just log 10, right? Same thing. So from here, they want us to change ln. Oh, base 10, right? So from here you can just write down, let's simplify it. So log e to a log e of 1000. Oh, I forgot to write, hold on. I'll just write this here. No, I'll redo everything. To base 10. So this is ln, or this is log 1000. But log e 1000. I'm making a lot of mistakes today. To base 10, right? So this is the same thing as what is it? This is the same thing as, okay, so log base 10 is just lg, right? So let's write it like this. So lg 1000 and then lg e. So this is just log 10, right? So I just wrote it like this. Now this seems a bit hard, like how are we gonna find log, like, you know, log 10 of e, but they don't expect you to do that, so just find log 10 of, you know, 1000. So this is just 3, right? Just what do you have to, what do you have to, if you raise 10 to the third power, you get 1000, right? So lg e. This is the answer. So then next question. Okay, I realized I did something wrong. Question 5. I said it was question 5 the entire time. It was actually question 6. So, you know, yeah, question 5 is easy. Question 6 is where it gets a bit harder. So then, now we're gonna change some stuff to base e, right? That seems a bit intimidating, but it's fine. Now 1 over log 6e to base e. Now, what are we gonna, okay, what the hell? Okay. So, what are we gonna do here? This, we can just follow the rules like normal. This is just, it looks like it's gonna, you know, use a different rule, but it's the same rule. So, 1, or I can just write down x is equal to 1 over, and then just the same thing. So, log e of e, which is just ln. So I'll write ln from now on so you get more comfortable with that. Ln e, and then log e6, right? Then from there, you would write 1, and then ln e is just log e, and the argument's e, right? So this is going to equal 1 with the laws of logarithms. So now you have log e6, right? Now this, you know, you can do the same thing. This is just the same as dividing by 1 over log e6, and then this is the same thing as multiplying by log e6, right? So then from here, 1 over log e6. From here you can just write down it's log e6, and like I said, this would just be ln 6, right? That's question 7a. Now next question. Now you may be thinking, alright, this is getting a bit easy, a bit too easy, so you may be getting suspicious, right? In actuality, most of the math we're doing isn't really hard at all. We just have really bad teachers. So, okay, we can use the, you know, same identity. So 2 log e, and then log e7. So this is just 2. This is ln e, and this is ln 7. Then from here, you can write 2 over 1, like we said, ln e is just 1, and log e7. Yeah, 7. So now let's do the same thing. This is the same thing as 2 divided by 1 over l ln7, right? So then it's the same thing as multiplying like this, right? So then from here you can write 2 ln7, and now like we said we can move this here, so then this would be ln 49, right? 7 squared is 49. Simple enough, right? So now we're gonna move to question 8a. So next one, question 8a. This is actually easier than the last one, so this is just 5. Okay, so we're gonna do the same thing, but we're gonna put it in reverse. So 5 log x is equal, if we move it here, then it's gonna be log x to the power 5. So we can do the same thing reverse, right? So we can put this here. So that's 5 log x minus 2, or this is 2 log x. So this is just 3 log x. Now, the question is, it's telling us to put it into this form, right? If you want, you could put it here, but it'd be wrong because the question told us to do that. So this is the second one. This is easy enough. 3 log x plus 3 log x. We just moved it here, right? So this would be 6 log x. Again, if the question told us to put it into x to the a form, if it told us to put it in this form, then we'd put this here. But it told us to put it in, this form, right? So we're gonna put this here. It's the coefficient, I guess. Now, next one. This seems hard. This is question number C. This seems like, oh, what are we gonna do here, right? This is easy. So, from here, what are these roots? Let's get rid of these roots, right? These roots are messy. So 5 log x to this 1/2 power. This is the same as a root, right? And then 3 log log x to the 1/3 power, because this is the same as cube root is the same as 1/3 power, right? So now, hey, we can move them here, right? Let's move this here, right? Or we could do another thing. We could just, move these here. It doesn't matter which way you do it, right? So, sure, let's move these guys here. So now it's going to be 5 times 1/2 x root log x. Log x minus log x. And this is going to be just log x, right? Because we're going to well, let me write it down actually. 3 times 1/3 log x. So we get 5/2 here. X minus 1, right? Get 1. So 1 log x. This is just the same as log x, so you normally not even write this, but for the sake of simplicity, we'd write this here. Now, what does this mean, right? This is just 2.5, right? So if we subtract 1 from 2.5, that would be 1.5. So that would be 3/2 log x, right? That's it. That's simple enough. So the next thing is a word problem, question 9. So the question is, the question is, there's a cube that has a volume of 800 centimeters squared, right? So we have to use logarithms to calculate the side length. So, you could do this pretty easily without logarithms, but they're specifically asking us to use logarithms. So for sake of, the book, we'll do it like that. So the area of the volume of a cube, that's just side square, right? So I'll write side square. Or side cube, sorry, side cube. So we know the volume of the cube. So 800. So they're asking us to find the side length here. So 800 centimeter cube is equal to side cube, right? Now, from here, we wanna get rid of this, right? So how do we get rid of this? So we're just gonna raise it to a certain log, okay? So it can be I'm gonna use LG for this, right? It can be okay. One thing to remember for the Cambridge exam, we're not really allowed to use the setting. There's a setting on the calculator. It's called log, and then it's a little box here, and then box here. You would put the the base here and the argument here, and you get an answer, right? We're not really allowed to use that like during the exam, but we're allowed to use the ln feature and the lg feature, right? So this is just it's the base of e and this is the base of 10. So let's use the base of 10. I would use base of e, but it doesn't really matter. It's the same thing. So it's the same thing if you're doing it to both sides. So log of 800 is equal to lg or log s cube, right? So this is the same as, well, I should probably write it like this, right? So this is the same as, you know, uh, doing this. Log 800 equal to 3 lg s. I write my s's like 5s when I do math. It's very weird. S. We can write this as x if you want as well. So from here, what you would do, here would you just you divide this by 3, right? And so you could remove this 3. So you divide both sides by 3. So that means lg5 or lgs. Oh my god, lgs. I should have wrote x here. lgs is equal to lg 800 divided by 3. Now you could use a calculator for this. So from here you would get lg s is equal to 0.9677. So now this is just log 10 of s, right? So we write this log 10 s because I'm going to show you something. 0.9677, right? So what do you have to raise the power of 10? Like what if I put this here, then I'm gonna get the answer of s, right? So because this is an equation, so therefore 10 to the power of 0.9677 is equal to s. So let's move up here. So now you would get from this equation, you get s is equal to 9.3. I'm pretty sure the answer is like something like 9.29, something like that, but 9.3 centimeters, which is 93 millimeters. Okay. So it's something. No, I think it's something 9.27. So you'd round it to the next whole millimeter. So it's 3 here. Now question B. So TSA, which is total surface. Right now the question is telling us, now that we have the side length of the cube, we're gonna find the TSA, right? So TSA is just the same thing as total surface area. So total surface area for a cube, since the cube looks like this. Wow, amazing drawing, honestly. Whatever. So there's 6 sides to a cube, right? So that means we have to multiply 6 into, or 6, we have to multiply this by the surface area of each of the faces of the cube, right? Which is, they're all equal, right? So then they would be s squared. Now we know s, so this would be 6, this would be 93. I'm going to use as millimeters squared. So this would be 6 times 86.49. This is just 51894. Oh, this is a. Instead of doing like this, I'm gonna do this. I'm gonna write it as centimeters and I'll convert it to millimeters later. So now, we have this as an answer, right? So this is the same thing as 51. This is the same thing as 51894 millimeters, right? Now, the issue here is in the book it says it's something like 517 or something. I am like a 9. I've literally checked this in like every possible like way, and it always leads to this answer. Like I've even used like Wolfram Alpha. They're all saying it's this. So the thing is for algebraic, like for like these types of questions where there's a lot of like margin for error. Like let's say for this, it's not actually 9.3. It's like something 9.27 something. There's some leeway you get, right? So if you show the process, they'll still probably give you marks for this, like most likely. If they don't, just a garbage school. I know O levels they would give you like marks for this, the examiners. So okay, this is the algebraic portion. This is pretty much it for the algebra, I think. So after this we have the graphical portion. That would be another video. But yeah, that's it. Yay! So great. Bye bye.